8-2, adding and subtracting rational expressions. In order to do this, we're going to have to be able to determine the lowest common denominator. We're going to add and subtract, and then we're going to go a step farther and simplify a complex fraction. So we already know this. If you are going to add or subtract a fraction, you have to have a common denominator. So I wanted to show you some elementary examples. So the first one is 2/3 plus 3/5. If you look at the two denominators, 3 and 5, the lowest common denominator, the lowest common multiple is 15. We can get a common denominator of 15 by multiplying the first fraction by 5/5 and the second fraction by 3/3. And you would rewrite your two fractions as 10/15 plus 9/15, just multiplying each number here. Now 10 plus 9 gives you 19, so our answer would be 19/15. Okay, and we can leave it as that improper fraction. But what do you do if you have these variables like a over c minus b over d? How do you get a common denominator? Well, if you take a look at the first example I did here, I really just multiplied the fractions by the opposite number, the opposite denominator. So if you look at these variables, I can get a common denominator by multiplying this first fraction by d over d and the second fraction by c over c. Now I've got a common denominator of c times d. So it looks like this, AD over CD minus, and then I'll just go BC over CD, just writing the letters the other way around here, putting them in alphabetical order. So then how do you write your answer? Well, the numerator is AD minus BC. We don't know what that is because we're working with variables. And the denominator, the common denominator, is CD. So this is how we want to leave our answer. AD minus BC all over the common denominator CD. Let's work on some more like that with these variables. So we've got 7x over 15y squared plus y over 18xy. Now we want to study the denominators, okay? So I'm looking at first the numbers 15 and 18. What's a common multiple? 15 and 18, and this might take you a while. They actually both go into 90. 15 times 6 is 90. So I'm going to multiply that first one by 6. And 18 times 5 is 90. Then I need to get the letters to match. So then I'm going to multiply this fraction by an x over x because this denominator has an x. And because this denominator has a y squared, I need another y over here. Okay, so we're multiplying each fraction carefully to get these to match. So what I'm hoping to get here now is a 90xy squared. And over here I'll have a 90xy squared. Okay, so now let's rewrite each fraction. 7x times 6x is 42x squared. Over, our common denominator here is 90xy squared. We're going to add to that 5y squared over 90xy squared. Okay, so now that we have a common denominator, we're simply going to add across the top. 42x squared plus 5y squared. I don't have any like terms there, so I'll just write them both separately. Over, now we keep the common denominator, which is 90xy squared. Now if you wanted to, you could look here to see if there's anything to simplify, but in this case there's not, and so this is our final answer. Here's another one. It looks a little different because in my denominators I have binomials. Okay, so study the two denominators. How can we get them to match? Well, it might help if you factor them first and then kind of see how you can get them to match. So I don't really care about the top of these fractions, but let's go ahead and think about these denominators in factored form. So I've got w plus 12 over, notice there's a 4, a common factor of 4 in each term here, so I would take out a 4 and I've got w minus 4 left in parentheses. We're subtracting this time. The second fraction has w plus 4 over, I'm going to factor out a common factor of 2 here. 2 comes out in front, and then we have a w minus 4 left. Now, the denominators are very close. We have w minus 4s in each case, but the numbers out in front are a little different. Here I have a factor of 4, and in this one I have a factor of 2. So how do I get them to be common denominators? Well, all I need to do is multiply this fraction by a factor of 2. Okay? That'll give me a 4 out in front, 4 times w minus 4, and up here I'm going to multiply by 2. I need to put parentheses around the numerator so that I distribute it through. Okay, so let me rewrite what we've got over here. We have w plus 12 over 4 times w minus 4 minus 2w plus 8 over 4 times w minus 4. I got this 4 out in front by multiplying 2 times 2. So now our denominators match, and once you have that, you're good to go. Now we can finish the problem. Now I'm subtracting here, so I have to be careful. It's w plus 12 minus 2w plus 8. So I really have to distribute that negative sign through, or just think subtract when we subtract our like terms here. Okay, so in the numerator I've got w's that are like terms. W minus 2w, that's like 1 minus 2. I get negative 1w, or negative w. Then I have 12 minus 8. It's the first polynomial minus the second polynomial. So 12 minus 8 gives me 4, positive 4. So now I've subtracted the two numerators, and my common denominator is 4 times w minus 4. Okay. Now, just studying this, if you wanted to go a step further, could you simplify it? Well, I'm kind of noticing that if I factor out a negative 1 here, if I pull a negative 1 away from w plus 4, it becomes w minus 4. Let's think about that. If I factor out a negative 1, I still have a negative w, but then I would have a negative 1 times a negative 4, and that makes plus 4. So if I rewrite it in factored form, I can actually get the w minus 4s to cancel out, because that's our common factor on top and bottom. Your fractions aren't always going to simplify, but in this case, I noticed that I had very similar factors on top and bottom. And just by factoring out a negative 1, you can actually cancel out the w minus 4s, and we're left with negative 1/4. So all of this up here, all of this work up here cancels out, and we get negative 1/4 for the answer. Okay, I'm going to show you one more of these. This time I've got a trinomial in the denominator, and I've got to try to match it with this binomial over here. So we have to get a common denominator. Well, it always helps to factor first. So I'm just going to rewrite this trinomial in factored form. If it factors, it's going to factor into two binomials. So 3x squared becomes 3x times x. And I have to think about the two factors of 5 that would work here. And in this case, it's going to be a plus 5 and a plus 1. 5 times 1 gives me 5. And when I multiply the outside, I get 3x. When I multiply the inside, I get 5x, and those will add up to 8. Okay, so that's the factorization there. And then over here, 12 and 20 have a common factor of 4, and I'm left with 3x plus 5, if you divide each of these numbers by 4. Okay, so I've got the common factor of 3x plus 5 in each one, but over here, I'm missing that 4 out in front, and over here, I'm missing the x plus 1. So here's how you decide what to multiply by. Remember, I need to get these factors to match, and we're looking at the denominators now in factored form. Okay, so out here I need a 4, so I'm going to multiply top and bottom by 4. Always the same thing in the numerator and denominator. Over here I'm missing the x plus 1, so I need an x plus 1 times an x plus 1 on the top too. Okay, now this is going to be a lot of algebra. It's going to get messy, so hopefully you can follow my handwriting. All right, so now we want to multiply this out. So I'm going to multiply the top. 4 times x minus 4 times 1. That gives me 4x minus 4. The denominator, just go ahead and leave it as 3 factors. 4 times 3x plus 5 times x plus 1. That's your common denominator. Remember, we needed all these factors in order for both of them to match. Okay, we're subtracting here. And then over here, I'm going to multiply these out. I'm going to use FOIL, basically. X times x is x squared. Then I have x times 1. That's 1x, positive 1x, negative 1x. And then negative 1 times 1 gives me minus 1. And then my common denominator, of course, 4 times 3x plus 5 times x plus 1. Okay, now let's go ahead and do all of the simplifying that we need to do. So remember, we're starting with this one on the left here, and we're subtracting any like terms over here on the the right. Now I'm noticing that this x and this x are going to cancel out, so let's just get rid of those. And let's go ahead and subtract like terms. Now, I don't have any other x squareds other than in this one, so it's going to be a minus x squared. See if I have any x's. I just have a positive 4x over here. And for the constants, I have negative 4 minus negative 1. That's a double negative there. Negative 4 minus negative 1 gives me negative 3. Okay, so there's the numerator. I've put the x's, the powers in descending order. X squared first, then the x, then the constant. And my denominator, this is the easy part. You just recopy it. Keep the common denominator, and now we have our answer. Okay? Okay, moving on to simplifying complex fractions. Kind of our last main idea here, and then this video is done. So we're really dividing fractions here, but if you look at the numerator and the denominator, you've got addition of fractions and subtraction of fractions, and that's why it kind of ties in with this video. So you want to look at just the top here. I'm subtracting 1 over x minus 1 over y. Well, I need to get a common denominator, so I'm going to multiply the first fraction by y over y, and the second fraction by x over x. Now I have the common denominator xy. Okay, so that becomes y minus x over the common denominator xy. I took y minus x, that's your numerator, over my common denominator was xy. Okay, now let's see what we have in the bottom part here. So look at just the bottom of this complex fraction. I really have 1 over 1 plus 1 over x. Well, the common denominator here is x, right? All I have to do is multiply this first fraction by x over x, and I've got matching denominators of 1x. Okay, so now I have an x plus 1, that's my numerator. X plus 1 is the top of the fraction, over my common denominator is x. All right, now that I've got the subtraction and the addition out of the way, I'm ready to divide. So remember, we're not really going to divide here, we're going to multiply by the reciprocal. So now you're going to want to rewrite the problem as y minus x over xy. Instead of dividing here, we're going to multiply by the reciprocal. So I'm going to flip this fraction over x plus 1. Instead of dividing by a fraction, we multiply by its reciprocal, and that's what I've changed this into over here. Okay, now multiplying, we're going to look for factors that cancel out. One thing I'm noticing is that I've got a common factor of an x on top and bottom, so I'm going to cancel those out. Remember, you can do this with multiplying. And now what I have here is a y minus x on the top. And in the denominator, I'm multiplying y times x plus 1. And I don't think there's any way to cancel out common factors here, so this is my final answer. So let me go through this process one more time. We had fraction on top and bottom here of a fraction, so it's a complex fraction. I had to get common denominators to subtract on the top, and I had to get a common denominator of x to add on the bottom. So once I did that, I combined the fractions. I was able to divide. Well, actually, I was able to multiply by the reciprocal of the denominator. Then we could cancel out an x and an x, and finally rewrite our answer. I'm going to show you one more of these, and then I'll have you try a problem on your own. Okay, so looking at just the top part here, this is a 1 over 1, so we have to think about this as adding two fractions, a over b plus 1 over 1. The common denominator is b, so I'm going to multiply the second fraction by b over b. Now my denominators match. My common denominator is b, and I'm going to add the top, a plus 1b or a plus b. Okay, now let's take a look at the bottom of the fraction. I've got a 1 over 1 minus a b over a. Well, my common denominator here is going to be a, so I'm going to multiply this fraction by a over a. And what I get is a minus b for the numerator over the common denominator is a. Okay, so now I'm ready to divide the two fractions, and remember we're going to flip over the second fraction and multiply. So this is equal to a plus b over b. That first fraction stays the same, times, now I got to flip this one over, a over a minus b. Okay, now when we multiply these, we want to be careful because I'm going to have to distribute. So I have an a times an a plus b over a b times an a minus b. And it's got to be written this way. We're multiplying here, so you got to use parentheses. And if you wanted to now, you could distribute. You could say your answer is a squared plus ab over ab minus b squared. There's nothing really to simplify here, so this is exactly how you would want to leave your answer. Or of course, this is fine too if you want to leave it in factored form. All right, now it's time for you to try one on your own. Go back to example 1 and watch that one here. You need to figure out what is your common denominator. So between 9 and 7, what's a common factor? And then how can you get the variables or the letters to match on each side? Remember, you're also changing the top of your fractions. So when you multiply the denominators, you multiply the top by the same thing.